Salut și bine te-am găsit pe startup.ro. Eu sunt Vlad Andriescu, iar astăzi vreau să te invit la o discuție despre inteligența artificială, dar nu numai despre viitor. Am avut invitat pe profesorul Philip M. Parker de la INSEAD, un specialist în inteligență artificială, un om care studiază acest domeniu de peste 35 de ani, care a scris 200.000 de cărți cu ajutorul inteligenței artificiale și nu vorbesc de nimic care s-a întâmplat acum un an, ci vorbesc de ultimii 30 de ani. Cu el vorbesc despre cum arată viitorul, ce am învățat din trecut, în cadrul unei discuții foarte interesante în limba engleză, dar care are și subtitrări. Vizionare plăcută!
My name is Philip Parker. I'm a professor at INSEAD, which is a business school that has campuses in Fontainebleau, France, Singapore, Abu Dhabi, and San Francisco. And I've been with INSEAD for a little over 35 years now, and I specialize in teaching and implementing artificial intelligence algorithms and methodologies across a number of industries and businesses, and I teach in our various programs, PhD, MBA, etc.
First of all, what brings you to Romania?
What brings me to Romania is an exciting project that I'm starting with Peter Barta, who, like many people, are interested in the use of technologies on massive scales to try to improve the economy, businesses, education, etc. And we're looking at a number of application areas that we're investigating together to launch in Romania. So I'm visiting here to meet with various entrepreneurs, people in government, etc., to see how we can implement best some of these advanced algorithms and techniques that have been developed at our lab at INSEAD.
Tell us more about those algorithms, those types of algorithms, and their scope, because you mentioned the private sector, the government also.
Yeah, very good. I'm somewhat of a serial entrepreneur in addition to being an academic. So way back in the day, we started working on the use of algorithms to create content in areas which don't have content, that lack content. And so we started by doing high-end industry studies algorithmically, kind of mimicking a consulting firm, but doing the same kind of work instead of in 6 months, doing it in a matter of 6 minutes, for example. So in the year 2000, we created technologies that produced over 50,000 high-end industry studies distributed on platforms such as Amazon.com or Standard & Poor's, Capital IQ, and others. And these industry studies gave us enough profit to create language learning books. The smaller a language is, the less is published in that language. So we started doing math books, spelling books, etc. Many of these have been donated by Rotary International to villages in Africa, Latin America, and elsewhere. And for the last 10 years or so, we started doing projects with the Bill and Melinda Gates Foundation, especially in this sector of agriculture and education, using algorithms to create weather reports and crop tips and things like that, mostly distributed via Android phones and or websites to help farmers in underserved languages around the world, in Asia, Africa, and Latin America. And right now, we're trying to expand the use of that technology for all known subjects across all topics, across all languages. But to do so, we want to work with local companies, local entrepreneurs who can take the code, take the technology, and then use it to its maximum for maximal impact. So that's kind of the history of the use of the algorithm. The types of algorithms vary. It depends on the subject. If you're doing weather reports, for example, you take direct satellite data, and then you use a supervised machine learning, which is a fancy way of saying statistics, and kriging, which is a fancy word for extrapolation, to make weather reports in local languages. This is information not available on the internet, not available from ChatGPT or LLMs. It has to be generated. The technology popularly was called natural language generation, NLG. Young people now use the phrase Gen AI, right? So natural language generation has been around for 30, 40 years now. Different algorithms are used depending on the end application. Weather uses kriging, soil analysis uses kriging, poetry uses computational linguistics. So different types of output require a different algorithm. And we have over 50, 60 different algorithms that are used depending on the type of content that's created. Spelling and math books uses linguistic graphs, for example.
because you mentioned that the newer generations use the term Gen AI right now, but you mentioned over 30 years of experience in this field. And I also read something that you wrote that the first examples of Gen AI can be found in 1967 with the first pocket calculator.
Yeah, exactly.
So what would be the difference, if you would be to explain it, between what we today refer as Gen AI,
Right.
and it's a popular field,
Right.
a financed field, and your work?
Yeah, so if you take the pocket calculator as an example, we'll use that. There's 4 branches to AI. So when someone says AI, it's not clear what branch they're talking about typically, but the first branch is robotics, using machines to mimic human intelligence in, let's say, welding or something like that in an automobile factory. The second branch is called cognitive or symbolic computing. The best way to characterize it in simple language is rule-based AI. Human beings can do the square root of 81. That's our intelligence. We know how to do that. We can figure that out. A pocket calculator takes the algorithm or the rule that humans use and simply implements it. So when you hit a prompt, you type in a prompt, square root 81, it answers, it gives you a 9, right? You don't want machine learning. You don't want it to learn anything. You just want it to follow the rules. Rule-based AI has been around a long time, and many trillions of dollars of value have been created from rule-based AI. The famous examples are IBM's Watson, which was a trivia show called Jeopardy where it could answer questions. Simple questions, simple answers. Like using ChatGPT, asking a question and it gives you an answer. That rule-based algorithm was Watson around the year 2010. Deep Blue was trained by IBM to play chess. It was given all the rules of chess and then would play chess against someone. It ultimately beat Grandmaster Garry Kasparov. That was rule-based AI. Expert systems where a software can diagnose a disease, computational chemistry, inventing new molecules. All of that entire field is computation, is let's say old-fashioned AI, rule-based AI, right? Google PageRank, for example, on how to sort search results. Those are all rule-based algorithms. Now, they can update and adapt all the time and refresh and come up with new answers. Weather forecasting models can be rule-based AI. The new branch of AI, which is what younger people are used to with ChatGPT, is because the price of graphics cards have plummeted so much, we can estimate neural networks. These are useful when you don't know what the rules are. Rule-based algorithms are often superior to large language models, which have a tendency to hallucinate. The problem is, maybe it's hard to code all the rules. So let the data do the talking. So the third branch of AI is more statistical in nature. If it's statistical in nature, where you discover the rules from data, it needs a lot of computing power. And thank goodness for the gaming industry and the Bitcoin mining industry, the price of graphics cards have gone down, making that third branch, statistical AI or machine learning AI, more accessible to more people. And the last branch is called machine learning control. It's about optimization. Like an autopilot in an airplane, you turn on the autopilot and the plane will fly itself. It's a form of AI which is optimizing. Don't fly too high, don't fly too low. Fly at the profit maximizing altitude to minimize fuel expenditure, for example. So machine learning control has been around for quite a while. Thermostats, instead of you turning up and down the temperature, it does it for you automatically. So a lot of automation is done in the fourth branch of AI. This Gen AI started in the second branch, rule-based. Now with machine learning, it gets more rich, right, with large language models. The ultimate future of generative AI is going to be what's called hybrid models or agent models or multimodal models, etc., where you're using pieces of the best case of all the different aspects into one particular algorithm or one set of algorithms that can generate even greater insights than we have today. So we're just at the beginning of that. We're just at the beginning of the intersection of all these things together.
You mentioned a bit of your work from before, generating basically intelligence in underserved languages. Tell me about the basically the intention that you had in picking those underserved languages, and what lacked that needed some sort of machine learning and artificial intelligence to solve it.
Yeah, for sure. If you ever go to an American bookstore, you'll notice there's a huge self-help section. There's tons of books for Americans in the English language. If you go to the French language, there's less books in French for self-help. And it's not because the French know what they're doing. That's not the reason. It's because there's less people who speak French. Therefore, the profit of publishing in the French language is not very good. So very few books are published in the French language for certain subject areas. You go to Italian, even less. Romanian, less. You go to Arabic, less. African languages, nothing. And we call that a content divide. That why isn't it that everything is not published in every language to the same depth and variety? And it's not for the lack of interest, it's for the lack of profit model. The cost of labor are so high that it can't be done manually. The market potential is too low. Algorithms, AI, reduces the marginal and fixed cost of producing content. If that's true, then we can use algorithms to perhaps fill the content divide. I started that with research reports for businesses on very obscure product categories. With the profits from that, we started doing language learning books for underserved languages. Now, the project is much broader in that, is it possible to not only create more content than all of the internet combined, right? But also make it of super high relevance to the people that you're trying to address. For example, if someone's in Kenya and they type in lump in breast in their native language, let's say it's Kikuyu, millions of people speak this, there's no results on the internet, about 3.5 billion people, there's no content in their native language. So they have to be bilingual, typically to a national language. So they'll go from Kikuyu to Swahili. Indeed, Swahili, no results found, no relevance. They go to English, and there's huge amounts of content. The problem is the content that they're seeing isn't relevant to someone living in a village in Africa. It's not relevant. Even if you translated the English into Kikuyu, it doesn't help the person in Kenya who has a different access to resources, let's say. For someone who has low income, what would be the appropriate text? There's not enough human beings to write the appropriate content. It just doesn't happen. And even if you had the right number of people to do it, they're very expensive. The cost of developing content on every known subject is just too vast. This is where AI can help, because you can automate a lot of what is required in content generation to an algorithm that can potentially produce things at an extremely high quality, no hallucination, etc., for those addressable markets. And so our lab at INSEAD has been focused on that for about 20 years now. And what we've done is different application areas. We started with agriculture, then we've done implementations with businesses, with banks, with other people, where frankly, without the use of an algorithm, the content could never be created. And I think what's interesting is that you have what's on the internet today that we can scrape and then summarize using what's called data reduction. And that algorithm will condense it down to a smaller footprint, and then we can explore that data like a large language model or ChatGPT, ask it questions, give it puzzles to solve. The problem with that is, and it's really good stuff, but the problem is it's limited to what it can find on the internet. Whereas content engines can create content that isn't even conceivable on the internet at this point and of high relevance to a local community. So it goes beyond what an LLM can possibly do because it's going beyond the bounds of what is obtainable by scraping existing content. And so I think that's a very exciting area. And the reason it's interesting from the language point of view, like you stated, is translating English isn't enough. Using content that's from the internet is not enough. We have to go beyond those boundaries, right? And that's what our lab is working on. And with Peter Barta here in Romania, what we're going to try to do is implement that on a massive scale. In the context of what's useful for both the citizens of the country, but also to the enterprises who have their ambitions. They have educational goals, business goals, etc. To what extent can these algorithms help accelerate what their objectives are to get to those objectives as quickly as possible?
And doing this, and I will take the example of Romania and launching this project here. What would be the wanted result in the end?
Right.
what type of content.
Yeah.
Because you mentioned the industry that can benefit the people. What will be created to be used?
I don't want to put boundaries on what will be created. It's really up to the local people, the people of Romania, to decide what should be created. We're working in a number of countries. We're working in Iceland, Iraq, Colombia, etc., all over the world in different projects. And it varies by country. I'll give you an example of Iceland. They want a lot more tourism to come to their country. That's what they want. The problem is there's no content in Chinese, Armenian, Arabic about Iceland. So the content engine is actually going to be used to encourage tourism from people outside of Iceland. The second thing that's going to be used is that they've noticed their language is dying because children are often, their kids are gaming and things like that. They start speaking English, they start mixing their native language with English, and ultimately, when they search on the internet for content in their native language, they don't find any results that are interesting. So they go to English in order to find information. That's true for IT professionals, right? You're going to type something in English and you find something there. The problem is it might not be relevant necessarily to the local culture. And what ends up happening is, because you can't find content in your native language, you end up abandoning your native language. So in some countries, they're very worried that their entire culture will evaporate just because they haven't been supported by content creation locally. Another application area that's getting a lot of traction is in the world of newspapers, for example. What you notice is that 100 years ago, it was always paper. And there might have been a national newspaper, 3 or 4, etc. And then the internet came. Then you had a digital newspaper that went with it. Paper's expensive, the print version goes under, or there's less of it. Now there's just digital newspapers. At local communities, rural areas, they cannot afford to have a web designer, a journalist, etc. It's too expensive to have local newspapers. Well, why not create algorithms that create local newspapers, complete from scratch? Not a news article, that's easy, but the entire newsroom, editors, journalists, the entire value chain of news can be created algorithmically. So we've started experimenting, launching local newspapers completely, and that's something that could be available, where the community news is actually generated for things that are happening on social media, for example. I don't know if you've noticed this, but there's this big trend where journalists will report about a tweet. Well, do you really need a journalist to interpret a tweet, right? Maybe you don't have to. Or they'll see something on YouTube, or they'll follow the minutes of a meeting, of a government meeting, right? And they'll read the minutes, and then they'll summarize what happened at a government meeting, et cetera, et cetera. There's a weather forecaster, right? There's a meteorologist, right? Can we write an algorithm to mimic? So imagine hundreds and hundreds of algorithms mimicking the different types of people depending on the type of journalism, sportscasting, et cetera. I patented NLG back in the year 2000, and I never enforced my patent. I let people freely use the patent all over the world, and people were writing news articles using our methodologies, right? They've been doing that since about 2010. The Wall Street Journal, Dow Jones have been using algorithms to write news articles for about 20 odd years now. And what's interesting is that many different aspects of journalism can be mimicked with an algorithm. If you aggregate them together, you end up getting an entire media company. And it's just a box in a closet and some electricity. And yet you can have a newspaper to a village, if the people would like to do that kind of thing. So the applications in Romania could be many. Language support, cultural support. Within businesses, it's very interesting. A lot of businesses want to go digital. They want to do digital transformation. Now, what does that exactly mean? It means that they might be sitting on a lot of data, but it's not exploited by the people in the company itself. It's kind of locked into a data lake. And often, it's not a linguistic type of report. It's not like they need a chat bot with their data lake. What they really need is a report on a future customer, who they should target, who's switchable, who's not switchable, etc. Kind of like a McKinsey & Company, a consulting firm in a box. Mm-hmm. So we've created algorithms that can create multiple types of consulting studies from someone's data lake. And we've implemented that, for example, in finance and banking, where salespeople want to know their customers better, not just sell products, but actually really know what their strategic problem of a customer is. Well, let's generate what would normally be a consulting engagement to figure out a company's digital strategy, their HR strategy, their import-export market strategy, summarize very quickly the strategic issues for a customer, and then when you visit them, you become a trusted advisor. A trusted advisor is someone who knows more than just the products they're selling, but they know the context of the company itself. So Peter, Barta, and I are now at the phase of we're starting to figure out what would be the best applications to start with within Romania, and from there, kickstarting many things, putting them on fast track to get things into different users' hands as quickly as possible. So we don't have a predetermined list of what would be the best application for Romania. It's rather a collaborative effort with our lab to kind of figure out what would be the optimal thing to be done.
I know, because you mentioned consulting and consultants. Also, I read something you wrote about using the content engine to work in reports. And you answered the question there in that article, but I will ask you again. What is the role of the McKinseys of the world, of the Big Four consulting firms? If you have the data, you can crunch it and you can interpret it to content engine.
Yeah, full disclosure, for about 27 years, I did internal training programs for McKinsey & Company, mostly teaching strategy and analytics and things like that. And if you step back and look at a consulting firm like a McKinsey or a Boston Consulting Group or A.T. Kearney or others, you'll discover that about 80% of what they do is fairly formulaic. They do an audit of a client, they summarize the data, they look at external factors, they summarize the data, they look at the intersection of the two. And because it's formulaic, if anybody is doing something that's formulaic, probably an algorithm can be written to mimic the formula, right? So, and if you look at what they do in terms of business, maybe 20% of what they do is strategic planning, things like that. 80% is, let's call it implementation, for lack of a better word. Two companies are merging. How do we optimize a new company? And that involves interviewing people, etc. Large language models or algorithms cannot help in that regard. So I don't think the consulting industry will evaporate, far from it. That's not going to happen. But certain aspects of what they do will be accelerated. So if someone needs to think about a global strategic import-export strategy, algorithms can race people to good insights quicker than in the old days, right? Where it was done manually, where you'd put a bunch of consultants in a room and they'd go on the internet, they'd get a lot of data from their internal information service, they would synthesize it. A lot of that work will simply be done very quickly, which means consultants will spend more time on the human-to-human interview process, collecting intelligence that is not captured in a digital format yet, but it's more interpersonal. And those will mostly be in implementation projects as opposed to strategy projects. They will have to adapt to this, by the way, because a lot of people will go to a business school thinking, oh, I'm going to be a hotshot analyst. That part of the business is going to be going, flat or down as a percent of the implementations people do. It will not disappear, however. There's always going to be a need for having agencies who come in on the short run, solve problems, identify problems, etc. for a company that's specific, and then move from there. It's more the strategic thinking analytics side that'll be fully automated or close to fully automated for many of these industries. So they're going to be still around for a while.
Stating at this topic, do you think we have been over a bridge when these consulting firms had the power in the 60s, and they did the same job, but let's say with pen and paper?
Yeah.
Then the internet and the digital era appeared, and they mimicked the pen and paper and now that can be replaceable through the technologies available today.
Yeah, and not just replaced, but maybe supplemented. For example, I'm working, I'm in collaboration with some firms where this conversation is being captured, right? Okay, yeah. And you can just do voice to text, right? And then someone says, well, summarize that conversation. What were the takeaways? And it can do that kind of thing, etc. So it's like spell check. Spell check in Word, that accelerated things, but it didn't stop people from writing, right? It didn't stop people from thinking and making decisions. So there'll still be decision making, etc. Even though algorithms facilitate some of the data collection and data synthesis, etc. So it's simply facilitating what we've done in the past, right? That's all that's happening. Some of the large consultancies, to be specific, will often buy a startup in the area of data analytics. They'll absorb them and then have a culture clash, typically. They can't quite do it. Well, now, that kind of startup being absorbed, it's more the other way around. There'll be startups that will replace certain aspects completely of some industries, and they will grow. Some industries have a very tough time adapting. I like using this little analogy with my arms. So this is a company that's brick and mortar, right? That's what they've done, a media company, like a television company, right? And then they add AI, right? And hope for the best. Mm-hmm. Okay, that's what the consultancy industry has been doing for a while, right? Versus a company that starts only with AI and then adds some people as they need it. This second model is now coming to dominate in the field of media, anybody in the content industry, consultancy, medicine, etc. So if you started medicine from AI and then say, what minimal humans do we need to have maximal impact, especially for people who wouldn't get medical treatment otherwise, right? You're going for underserved segments, right? There will always be the brick and mortar methodology for many things, psychology, for diagnostic care, urgent care, etc. When you break your leg, it's going to be a long time before AI takes over, right? Mm-hmm. However, for a lot of things that people need, which is purely content, diagnostics, for example, you start from AI and then add labor. And you find out that that second case is often far more profitable than the first case, which is starting with brick and mortar. Often they can't transition. They just can't. Their people aren't maybe the right mindset. They don't have the right training. They don't have the right background. And their overhead structures don't allow for an AI lab. On the other hand, if you start from an AI lab and then say, let's spin products off of it, they're already starting from an appropriate cost structure. They're much more flexible. So a lot of media companies, for example, as an example, healthcare companies, they're in that struggle. Do I abandon the old thing and start this new thing? So what's happened is a lot of companies add AI, but some will launch a speedboat. So one's a tanker, and then a speedboat is launched, a separate entity that doesn't interact with the mothership, so to speak. And then it goes on its own. Those startups are very interesting because they might be the future boat, whereas this one just declines in format. I don't really work in that area as much as how do you serve people who cannot be served unless it's with AI? A local community newspaper, for example. Without AI, it simply can't profitably be run. So we might as well use algorithms to fill the gap. Underserved languages, underserved businesses. How does an SME, small company, afford McKinsey? They can't. Well, let's create algorithms that give them the advantage of being able to look at what McKinsey could do for them, but doing it at a very lower price point, right? And that's a kind of thing where AI can lift all boats, right? That, I think, is the most exciting area right now in AI.
One argument, a more subjective argument, would be about the use of the information, because you mentioned scrapping the internet, and we have seen crashes between large language models and maybe big newspapers as the New York Times, for example. How do you balance the need for information that a content engine and artificial intelligence needs with intellectual property and a fair use of the information already available?
Okay, this is a really touchy subject. I could speak hours on this. From the point of view of intellectual property, as you know, knowledge is public domain. So if a newspaper writes something, anything that's factual, they do not own it. They own the copyright over the phrase that they wrote or the sentences, but they don't own the knowledge that's been released. Whenever a professor says something to you, you now have that knowledge. It is public domain at that point. So what the challenge is for generative technology is to make sure they exploit the public domain knowledge as much as they possibly can. Now the problem is often the public domain knowledge is locked in copywritten material. So the bridge between going from copywritten material to public domain knowledge is where the legal action is, the moral action is, right? Academics, we actually have the right in fair usage that's different than non-academics in the United States, for example. We're allowed to have quotations that are longer than a commercial person. A commercial person isn't allowed to make money off of copywritten material except under fair use. But professors, for example, I can use as much as I want as long as it's in the context of teaching. So the laws vary from country to country. In America, we have very liberal laws on this. I can do a parody of something that's copywritten. In other words, a newspaper generates some articles. As long as I'm making fun of that article, I can use all of it as a parody. So if someone classifies large language models as making fun of journalism, that is full use. They can use whatever they want. If they're using it and repurposing it for commercial purposes, then it becomes interesting, because am I using the knowledge of the newspapers, or am I using the actual text of the newspapers and then reproducing it for commercial purposes? So what a lot of large language model companies are doing right now, in order to avoid antagonizing content creators, they're trying to create business deals between the creators and themselves. In the world of high-end research studies, I was approached recently to say, would a large language model company said, can we use your research reports as inputs into our large language model? Which is ironic because our reports are generated by computers, right? So they're asking a generative company, can we use your generated content in our content? And they want to have a license to do that. Now, they could literally buy the reports and just use it, right? But they're worried about that kind of a business arrangement. So right now, we're at the Wild West frontiers. People are trying to find out the appropriate contracts, and those contracts vary by country. And because laws vary by country, in Germany with GDPR, individually identifiable information can never be used, right? So there has to be filters. There has to be companies in between the large language models and the content creators to make sure that you're not violating laws. So it's a minefield at this point. It's Wild West. So a lot of companies are asking for forgiveness rather than permission. They race ahead and they find out who's complaining. And then based on those complaints, they'll adjust their intellectual property rights, their moral compass, so to speak. They'll try to understand better what they can use and not use. It took about 20 years for Google, for example, to sign agreements with the news industry in different countries like Spain. But it required lawsuits before that negotiation took place. So by and large, the large tech companies assume they can use whatever they like as long as it's on the internet. That's kind of been their philosophy, but that's changing, right? It's modifying. So you notice that Google News has a news branch. You start seeing the big techs creating their own content companies to kind of disintermediate local companies. So that's kind of what's going on right now. It's a bit Wild West. I wish I could give you a specific answer, here's the rule, but people are discovering what works and what doesn't right now.
I know that you also developed at the INSEAD a Toto poetry.
Yes, it's Toto poetry, yeah.
What was the premise of the project, and what have you learned through poetry in the use of AI? So
we were able to create algorithms that write poetry probably about 15 years ago. We just played with it. It was a New York Times journalist who said, can a computer program beat Shakespeare in terms of quality? And I said, well, I don't know. I haven't written an algorithm that writes Shakespeare yet. So we decided to do it. And we had high school students compare the algorithm to Shakespeare. And they preferred the algorithm, the computer-written Shakespeare, because Shakespeare is very hard to read. It's Elizabethan English. It's very complex. So they preferred the computer text. And then when we told them after the fact that it was computer-written, they even liked it better. The young generation thinks it's actually kind of cool that it's computer-generated, therefore maybe be less biased for some reason or whatever. There's not a negative connotation to computer-written content. That doesn't surprise people. But what we noticed was that poetry follows very specific rules. The reality is there is no such thing as a poem. That doesn't exist. There are genres of poems. There's sonnets, limericks, haiku. False. There's no such thing as a sonnet. There's Elizabethan sonnet, there's modern sonnets, etc. As you go down the branches of the genres of any style of writing, when you get to the bottom branch, you've hit the formula that humans use. When you program a computer at that level, it's specific. It's called weak AI. Weak meaning it can only do that one purpose. Kind of like Deep Blue could play chess, right? It could play chess, but it couldn't do other things, right? So the poetry algorithms we wrote were to demonstrate that writing styles are highly formulaic, and then once you know the formula, you can replicate it. This is kind of where large language models are not as good as NLG algorithms in some regards. For example, if you ask ChatGPT to write a limerick, it will write a poem, but it's not quite a limerick, this Irish poetry genre. That genre of poetry, a limerick, is used in pubs by men mostly. And they use euphemisms to talk about women in the village without using their names. And usually it's kind of a little bit risque, if you want to know. And if you ask ChatGPT, because it censors, it doesn't quite get the idea that it's about a person, and it's kind of using innuendo, right? Those subtleties are formulaic in nature, and a language model can't pick up those formulas. It can't see it necessarily. So it produces something that kind of looks like a limerick, but it's not really what a limerick is, right? And that's one of the dangers of large language models. Children will say, write a limerick about this. They'll get ChatGPT and they'll assume that is what a limerick is because it produced it. When in fact, it is not a limerick. It's simply a poem with 5 lines, which limericks have, but it's not really a limerick, if you know what I mean. So there's ways to go. So we did the poetry project because we wanted to just illustrate how creative an algorithm can be. And often poetry is seen as a highly creative endeavor, but even in the world of creativity, there are genres of creativity, different types of painting, impressionism versus, modern, neoclassic, etc. So the idea was to show that that was true in linguistics, right? That there were genres of writing styles. And we chose poetry because a journalist, it was at the New York Times, asked me about, can it beat Shakespeare? Can it do better than Shakespeare? And amongst teenagers, yeah, it can do better than Shakespeare. But Shakespeare is still genius because Shakespeare invented genres of poetry. Large language models don't invent new genres per se. They're mimicking within a genre of poetry. So there is still room for genius, creativity, coming up with brand new methodologies. That's what humans are very good at, whereas algorithms are good at implementing within an existing genre, not inventing them.
And in the general topic of the role that we as humans have in this AI decisions-based world, where is the human? Where is the man in the pub in Ireland, or the place for geniuses? I don't know, to make a comparison, as that expression from cybersecurity is the man in the middle.
Yeah.
Where are the humans in this algorithm?
Right. Many people ask that question because they're thinking about employment. What are people going to be doing in the future, right? If your job is sitting in front of a computer screen, there will be an algorithm that will replace you. If your job is meeting people, interacting with people, interviewing people, you're safe. Things are going to happen, right? If that's what your career is all about. It's about human-to-human interaction, right? So the guys at the pub are still going to be there. They're not going to disappear. The beer will be maybe slightly better quality because an algorithm might have determined a certain level of an ingredient which makes people taste better beer. But it won't replace beer, it won't replace the people, etc. Most AI today is very primitive. It is not advanced at all. The hypothalamus in the brain, the limbic system, still hasn't been modeled by AI yet. Fear, feeding, fighting, romancing, all those kinds of things haven't been modeled yet. We don't even have a bumblebee modeled yet, right? So we're not even close to having some kind of replacement for humans with artificial intelligence. Nowhere close. I mean, this is all science fiction kind of stuff. That being said, people are afraid of AI to some degree. When the pocket calculator came out, especially the commercial pocket calculators, they were banned from schools. Kids were not allowed to bring calculators to class. Everyone feared that no one would learn mathematics anymore. Well, the reality is my generation learned how to do long division, or we learned how to by hand do square roots to like the 4th digit by hand. No one knows how to do that anymore. Young kids don't, you say do it by hand, they just don't know. That skill isn't really necessary if you have a pocket calculator. It makes people more productive. They're able to do more things with automation. So the human comes into the equation by saying, wow, I used to be able to only write 1 book a year if I was an author. Now I can write hundreds of thousands in a year. So then the question is not about productivity, but what's impactful. If you got an algorithm, how do you have impact on humanity? Not on other algorithms, but your impact on humanity. So the trick will be, I've got a calculator. Great. What's the use case? How can I make this useful to people? What can I do? So the creativity comes in the use case of entrepreneurs, people trying to figure out, oh, I've got this large language model. What can I use to make people more productive, etc. So that's where the game is with humans and AI, is humans judging how to use AI for some benefit to other humans. That's where the name of the game is. But for by and large, you're still going to wake up at the same time in the morning. You're going to go through your breakfast routine. You're going to go to work. You're going to interact with human beings more so than you will computers. You'll end up doing projects, implementing things, and then you'll end up enjoying entertainment. Some of that entertainment will be characterized by a computer program, but a lot of it will just be podcasters talking because you like the people and you're going to be interacting human to human. So I don't see major upheaval per se, except in some narrow industries like the consulting industry, like you said. In banking and finance, they'll be so much better at identifying customers, switchable customers, people like that, growing their market shares internationally, tripling the size of their business, because now they can use algorithms to help them in doing that, aspiration. I want to triple my company. I don't have enough people I can hire. How can I use algorithms to grow my business without hiring people? Those kinds of applications we're just at the beginning of. And so I'm pretty positive on the human benefit of all of these things, despite there being a lot of articles about, the world's coming to an end. Far from it.
Thank you very much.
Thank you.